Ladies and gentlemen, once again, I'm Lo, your moderator for the keynote address on climate change and the tropics. This will be addressed by Professor Dr. Jacqueline Pereira, Fellow of Academy of Science. A short intro on our keynote speaker. Prof. Joy is currently the Vice Chair of the Intergovernmental Panel on Climate Change, IPCC, Working Group 2 on Impacts, Adaptation and Vulnerability. She was the coordinating lead author for the Asia chapter of the IPCC 5th Assessment Report, released in March 2014, the review editor for the 2012 IPCC Special Report on Managing Risk of Extreme Events and Disasters to Advance Climate Change Adaptation, IPCC SREX, and the lead author for the IPCC AR5 Synthesis Report. Prof. Joy chairs the Malaysia Research Network on Climate, Environment and Development, MyClimate, and serves as a resource person to the Malaysian government in negotiating international agreements. She is also the chairperson of the ASM Disaster Risk Reduction Research Alliance. Without further ado, please welcome Prof. Joy Jacqueline Pereira to present a keynote address. Prof. Joy, the floor is yours.
Thank you, Mr. Loh. Selamat pagi, tuan-tuan dan puan-puan yang saya hormati, khususnya ahlian yang hadir daripada Academy of Sciences Malaysia. Jadi, terlebih dahulu izinkan saya mengucapkan ribuan terima kasih atas peluang untuk berkongsi beberapa penemuan daripada laporan IPCC yang berkaitan dengan kawasan tropika pada hari ini. Dan di sini saya ingin menyatakan yang memang perkara-perkara ini belum lagi ditarik keluar dari segi melihatnya dari aspek tropika, ya. Jadi izinkan saya meneruskan pembentangan saya dalam bahasa Inggeris. Dan terlebih dahulu saya akan mengurangkan bandwidth saya supaya tiada gangguan, ya. Okay. Slideshow. So with this, let me start by saying that this is a privilege for me again, and I'm very glad to be here. And I will just start with a small background on IPCC in terms of how it was established jointly by the World Meteorology Organization and UNEP in the 70s, and then it has released several reports. The first assessment report, the second over the years, and right now we are in the 6th assessment cycle. And in terms of the science, we are looking at the peer-reviewed literature, and there's a growing public awareness of our work, and the involvement of various actors are increasing. And in terms of the impact, IPCC was recognized with Al Gore with the Nobel Prize in 2007, you may recall. And what has the report of the IPCC been used for? The very first assessment report was led to the establishment of the United Nations Framework Convention on Climate Change, which is the platform for negotiating climate change arrangements. And the most recent report, which is the 5th assessment report, served as an input to the Paris Agreement. So in terms of the products for the 6th assessment reports, we have already released this landmark 1.5 degrees global warming report. We've had emission and inventories updated. Ocean and cryosphere report has been published, and a land report was also released. And all these 3 reports have elements of the tropics, which I have pulled out today for our perusal, if you will. And I will start by taking you through where we are now, and then touch on what happens if we just ignore the science. Where will apathy take us? And what kind of actions we can take. And I'll just finish off with a couple of projects that my institution is doing to as a contribution of tropical sciences to the world. And in terms of climate change, you know that it's already happening from the tropics to the poles in all continents, in ocean, but it affects both rich and poor countries, but it is the very poor and poor who are most vulnerable everywhere, irrespective of where you are located. And science has already proven that the human influence on climate change is unequivocal. And in terms of the changes that we are seeing, we already see decreases in cold temperature extreme. We are seeing increases in warmer temperature extreme and high sea levels. We are looking at the number of precipitation events that are increasing. And the atmosphere is changing fast because of the fossil fuel and the GHG emissions from the energy sector primarily, as equally from the agriculture sector, from industry and transportation, as well as the building sector. So we have all these sectors to contend with in terms of the economy. And as a result of the economic development, where are we now? So according to the IPCC, the science that we have reviewed indicates that we have warmed 1 degree Celsius in 2018. So we are in about 1.1, 1.2 now. And we are already seeing the consequences for people, for nature, for livelihood. And we are expected to reach 1.5 degrees between 2030 and 2050, depending on the pathway that we choose to follow. And the good news is that we do not have to commit ourselves to this. We can change the pathway that we take. And this is very important because the choice of what we believe in, whether we choose to believe in the science or not, depends on us. And what does the science say if we were to ignore all the science, all the information that has come through? So this is the bar chart where purple shows very high risk, red is high, moderate is yellow, and undetectable risk. So if you look at this horizontal gray bar, this is where we are today. And if you see unique systems, you are threatened, extreme weathers expected. This is a reason for concern. And then the distribution of impacts in terms of whether how they are going to play out, as well as the large-scale singular events that come in. And looking closer, if you look at the risk, and again, you will be familiar with this chart, this gray horizontal bar is where we are now. And look at the purple and red zones here that we are going into in the terms of the warm water corals, in terms of the fisheries, and the Arctic, of course. And then look at coastal flooding that's going to become problematic in the tropics, especially you will see later, and fluvial flooding and heat-related morbidity and mortality. So this is a global overview. But the reality is that the impacts of climate change, they are spatially differentiated. But let's look at the global warming of 1.5 degrees compared to 2 degrees Celsius. So it's very small, 0.5 degrees, but by limiting 1 to 1.5 degrees, we will have less extreme weather. Sea level will be about 10 centimeters lower, although it will continue to rise. 10 million people fewer will be exposed. There'll be a lower impact on biodiversity and species if we are to limit warming to 1.5 degrees. We have smaller reductions in yields of maize, rice, and wheat, and water shortages will be reduced by half if we were to limit warming to 1.5 degrees, and we have lower risk to fisheries. And in this difference of 0.5 degrees, the climate risk that affect people ranges to several 100 million people, souls, if you will. So if we limit global warming to 1.5 degrees, several 100 million fewer people will be exposed to climate-related risks, will not have to, they will not be susceptible to poverty, they will not be needing to migrate and move away from their homes. So imagine several 100 million fewer people. And if you think about the refugees that we have today, that's 80 million people. And we don't know what to do with this. Imagine several 100 million people coming down the way in a 1.5 degree compared to 2-degree world. So as I mentioned, I want to stress that the impacts of climate change is spatially differentiated. And the projection is that Southeast Asia, tropical Southeast Asia, is going to experience the largest impact on our economic growth. And where is apathy going to take us? In terms of the differentiated impact here, this is what I have pulled out. And very rarely do we see this kind of display where I've pulled out all the key findings from the IPCC for tropical Asia. This is only for Asia. For tropical Asia, you can read as Southeast Asia. Temperate Asia, you can read as India, China, who have large tracts of temperate land. Arid Southeast Asia, arid Asia would be represented by the Middle East. And what you see, this red, this pink, light orange colored cells represent the negative impact. So heavy precipitation associated with tropical cyclones, we expect both in the tropical as well as parts of temperate Asia. Net reductions in yields of maize is exclusive to tropical Asia, as is the hot days that are projected, and as is the impact on of economic growth. And this is from the special report on 1.5 global warming. Let's look at what the special report on oceans tell us on the differentiated impacts of oceans. You will see tropical Asia has the privilege, fortunately, of being exposed to marine heat waves. The most of marine heat waves will have significant wave height increases, which will then affect our coastal regions in terms of the hazards that will come. And then the global biomass and marine and animal communities will be affected. And if this will also affect the fisheries catch potential, and the rate and magnitude of decline are projected to be the highest in the tropics. And tropical net primary production is expected to decline by 7 to 16%, with challenges in tropical Pacific Ocean with respect to fisheries governance. So I've extracted the whole key findings for you so that you can see that this is not a sensationalized report, but it's just flagging to you what awaits for the tropics. And in terms of the differentiated impacts on the land report, and you will see that for tropical Asia, we have millions of lives will be in jeopardy due to cyclone, especially in cyclone-prone areas. And yet you have blue here, which is a positive impact of climate change in temperate Asia, where they have lengthened growing seasons. We can expect that. And in tropical areas where rainfalls are increased rainfall is projected, we will have either positive or negative condition resulting on the severity. And where forest cover increases, cooling will result. And again, here it depends on our actions. If we have more forests, we have more cooler climate. And that's again positive or negative depending on our action. But in temperate Asia, it's going to be largely positive. Coming down to the emissions scenarios, in our high emission scenarios for tropical regions, we have the emergence, expecting to have the emergence of unprecedented climatic conditions covering both the tropics and temperate regions of Asia. So this is how the impacts are differentiated. And this is totally different in concept from mitigation. Mitigation of climate change is very easy to differentiate. You want developed countries to cut down and on carbon emissions and developing countries to have room to grow. But from these impacts that you see that are projected, you see that tropics are going to suffer get the highest impacts. So perhaps the strategy of calling for mitigation, yes, we want the developed countries to cut down, but we also want developing countries with high levels of emission to cut down as well, because every bit of warming is going to be important. And this is the aspect that is different from climate change adaptation and mitigation. And what actions can we take now? There are no solutions. It's not a scenario where we don't have any actions, no solutions inside. So the IPCC has reviewed and come up with that with peer-reviewed literature with evidence showing that we will need unprecedented scale kind of actions, and this is examples of these are deep emission cuts in all sectors, not only this oil and gas, but also in transportation, but for all types of gases. We need to deploy a range of technology. We need to have behavioral changes and increased investment in low carbon options. These we need urgent and far-reaching actions for, and emissions need to peak by 2030, and fall carbon dioxide emissions must fall by 45% by 2030 to reach net zero around 2050. And this is not impossible. We also need to ensure we have ethical and fair transition. The transition must be just, and the limiting of this calls for political and societal will, and we all have a role to play here. So the IPCC has identified 4 pathways that can take us to this carbon dioxide emission reduction scenario. Not be that as it may, we still need methane emissions to reduce, we need black emissions to reduce, and nitrous oxide emissions to reduce. And by reducing these gases, immediately we get the benefit because we'll have cleaner airs in cities. So this is a no regret option for the developing world especially. And of these 4 pathways that IPCC has identified from P1 to P4, my favorite scenario is one with the social and business where there's so much of innovation. And of course, the scenario we all want to avoid is one where there's high intensive carbon dioxide removal technologies coming into play in the form of biofuel energy, carbon capture storage, which is going to be a very expensive thing for humanity. And I'll just take you through this easiest scenario, which we can do now, is to, and where we take action in terms of in social actions, in business actions, we take technological innovation, and we don't deploy BECCS technology. And what happens in this scenario? How does it implicate us? There'll be coal removal totally, 97% of coal removal. Energy and oil has to go, energy from gas has to reduce. So all these reductions are critical to have this kind of a limiting pathway to limit global warming from the in the global sense. But if you wait until where you need intensive technologies to be deployed, you will see that in this scenario, coal is still removed from the system. Of course, oil and gas, you remove even less. You have to remove this to cut down this and have a just transition in this context. But again, this is a very expensive scenario. And people say, well, if I do take climate action, is it going to compromise the SDGs? You look at the science, this is SDG 1 to 17, and the science, the peer-reviewed literature has been indicates that they've looked at energy supply, energy demand, and land. The longer bars here show the trade-offs and the synergies, and the shades whether are the confidence level, and blue is the synergy, and the brown is the negative impact. So all you need to see is look at these SDGs from 1 to 17, and you see that the blue bars are so much more and longer than the negative bars here. So what it indicates is that doing climate change mitigation doesn't take away anything from achieving your SDGs if you're carefully deploying it. And this is an important message to take away from this event. And in terms of our contribution to tropical sciences, indulge me as I share some of the findings, but let's just take note first that adaptation is already occurring everywhere. And if you don't know what adaptation is, it looks like this. It's about disaster risk management. It's about planning for sea level rise. These are things you know. It's not something from far away that you don't recognize. So if you look at Asia, we have development planning, we have early warning systems, mangrove reforestation, water resources management. All of these are adaptation actions. They are embedded in them. And if you want to take risk management and adaptation actions, they must be tailored to the local need. Because the climate extremes vary, regions are different, the impacts are spatially differentiated, and the effects of these risk management actions actually must take into account the local communities in terms of their exposure and their vulnerability. So adaptation is very, very site specific. And if you look at Malaysia, what we have done is taken disaster risk reduction as an entry point in many ways, implicitly, without recognizing it as an adaptation action. So the majority of disasters that affect Malaysia and Southeast Asia for that matter are climate influence, such as flood, landslides, storm, drought, and these are expected to account for 30% of total GDP loss of cities in the future. So if you look at the disaster management cycle, you go through prevention, mitigation, preparedness, response, and recovery. The first step that IPCC advocates is that taking to adaptation is to reduce vulnerability and exposure to present-day climate and variability. In this context, we have opportunities for climate change adaptation within the disaster prevention, mitigation, and preparedness component of the disaster management cycle. And even as we recover from disasters, we can, through the recovery process and prevention and mitigation, we can take climate change mitigation action. And this COVID-19 situation is an excellent example of how we can now transition if we are careful and strategic in our investments for recovery. And this is the way we take into account all the three global agreements on disaster risk reduction, the Sendai framework, the SDG, on climate action, as well as the Paris Agreement. So if you think that, these things don't affect me, stop, think again. This is examples of incidents in Greater Kuala Lumpur, where you see we have landslides and floods incidences recorded from the newspapers in this particular case, and reports that last seconds and hours, to fluvial floods, to coastal inundation, peat fires and haze incidences. And we also have these elements that need more research in the tropics in terms of land degradation, what's the impact of sea level rise, groundwater salinization, because these have years of unclear start and ending. And our work in the tropics, our colleagues are all doing work today, and you will hear from them. These are the kind of things that will contribute to science in the tropics with respect to climate change. So the questions that we have to ask are very important in science. We don't want to know why the climate is changing. Okay, that's the wrong question. What we want to know is, what are the new risks? Where are the vulnerable groups? What are the exposed assets and supply chains? Very sharp questions to be answered for our region. And we have taken a local level initiative in Kuala Lumpur, supported by Innovate UK and MITE under the Newton Unku Omar Fund, which is a wonderful program to bring collaborations in the country, which should be expanded, I think. And we've looked at disaster resilient Kuala Lumpur. I had the privilege to lead this with Lord Julian Hunt from University of Cambridge. We looked at downscale meteorological parameters. This was done by our colleagues from the Meteorology Department of Malaysia. Wonderful colleagues there who worked to downscale it to 300 by 300 meter for the first time in Southeast Asia, or for a tropical region for that matter. And this was then used to drive geophysical modeling for the geophysical hazards and atmospheric hazards. My colleague, Professor Talib, also a fellow, was involved in this. And together the physical people brought it, and the atmospheric people brought it together, these findings together into one multi-hazard platform to help the City Hall of Kuala Lumpur to have local weather forecast right up to hazard forecast and disaster alert. And unfortunately, the findings of this work, and here you will see how this platform actually now sits in the City Hall of Kuala Lumpur. The findings of this work, like in this particular case, where are the red zones, are all the areas that are susceptible to Kuala Lumpur at the street level as revealed by our findings. And we looked at the hospitals and schools and fire stations and police stations that were recorded. Unfortunately, the findings of these results is not going to be shared with the public. That was a decision the City Hall took. So again here, from the academic perspective, open science information becomes very important. These are science information, and a more resilient community can be developed if they know what are the hazards they are exposed to. And given that experience with the City Hall of Kuala Lumpur, we are now working with the state of Selangor, which has a Freedom of Information Act, and funded by the IDRC. We are taking an open access data approach to actually develop local level disaster resilience plans, which will then integrate disaster risk reduction measures in the first instance, and then take on climate risk in a very integrated manner, where we will use community information through crowdsourcing, and also work with the Smart Selangor Command Center, who is the lead project. And this specialized collaborative approach, the intention here is that it be led by a social entrepreneur so that it becomes a very sustainable initiative. So these are some of the key queries that has to be addressed as we move forward to advance in climate change adaptation for our country. How do we do a just transition? How do we should be carefully costing transition of risk, risk transition against the risk of physical impacts and risk of liabilities. And what can we have greater collective context? So every bit of warming matters. You've seen that the difference of 1.5 degrees and 2 degrees is small, only 0.5 degrees, but the difference translates into climate risk exposure to about 100 million people. But every bit of warming measures. But why? The people ask, why should Malaysia bother to take this action? Our contribution to the global GHG emission is small. Our contribution may be small, but we are going to be very much impacted. So the faster we push everybody to limit global warming to 1.5 degrees, and we ourselves make the transition, the quicker we can adapt, and the lesser will be the risk. So every choice matters. Every year matters. The longer you delay, the more expensive it becomes. And the COVID-19 recovery plan is an excellent start for climate action if we make that choice. So those of us who have this privilege to know, I think we have a duty to act. And in that context, I challenge my colleagues in the academy to rise to the occasion and contribute to tropical science in this context. And thank you very much for listening to me.
Thank you very much, Prof. Joy, for the insightful keynote speech. Since we now know, we must now act.